Welcome to the Minigame Project series. In this playlist, we're going to be diving into a collection of interactive, browser-based minigames, each designed to showcase some versatility and simplicity of jQuery for DOM manipulation and event handling. Well, why jQuery, you might ask? I went over this more extensively in the first video. You can also look at the README of this GitHub repository, which is linked in the description down below, which will go into further detail, but TLDR, still a powerful tool, easy to use, cross-browser compatible, vibrant community support, and it's still used by like almost 80 million websites out there. So why not learn something old school, have some fun? I'm tired of doing React MERN stack projects anyway. Let's change it up and have some fun. So by using jQuery, I'm going to make web development more accessible for the newbies out there and fun to learn for the old heads, right? So, join me as I explore some different game mechanics, tackle coding challenges, unleash some creativity, all the while honing web development skills. Whether you're a beginner or experienced, hopefully you can find something out of this. So we're going to dive on in and keep on coding from where we left off in the last video. We got our basic project structure written out, covered why we're doing this, wrote out some styling and a click listener and some HTML to make some cards appear in the browser. And not only appear in the browser, there we go, I had the wrong scene selected there. Hashtag professional right there. I'm not going to fix that in post, I'm going to leave that in. We had a very dope looking set of cards that could be clicked and they would flip on back over after some time had passed. And again, you could grab this repository from the link down below, clone it, fork it if you want to contribute something cool to it. Or if you have ideas for future games or things you'd like to see. I'm not a game developer, but I'm trying to learn here. We had it working fairly simply, and now we're actually start building out some more of the actual game logic and have these cards, hard coding them in the HTML will be fine, but it'll make the game kind of boring once you know what their positions are. So we need to make these dynamically generate from the JavaScript code and be able to be shuffled. So, we're going to leave one card here for now. You can't tell this is part of a playlist, so please watch the first video if you're new here and you're trying to follow along. Otherwise, let's keep going here. So we're gonna leave the card here for now, just one card, and we're gonna come back and generate this from JavaScript here. So before I go into that, though, I'm gonna go ahead and cover something we're gonna do here for our cards. Right, we're gonna do this for the rest of the code base. I'm going to comment that out because I might want to grab something from it, but for now we're going to leave that down there and comment it out. That was just like a quick test I want to do in the browser. So, I have it all up and running here. It's ready to go, and what we're going to do is we're actually going to do it this way. Now, we could do this with OOP. It'd actually be kind of cleaner and easier, but I'm going to keep it pure function or functional programming. I am not going to use object-oriented programming as well. Some of my old heads that might be watching this know that stuff. If you're a student in our curriculum or an alumni, you know OOP because we have a module in it in our course, which if you're interested, check out the description down below for a link to our community membership. You get access to our front end, back end, and my React course. Any updates that I add to them, which I do regularly, and any new courses that we add, which I have a few in the works right now, they get added for free in that membership, and you get access to me and our alumni and our staff and other students that want to learn in our Discord community. So check it out. Otherwise, like I was saying, I'm not going to do OOP on this one. So we're going to keep it purely functional, but I still want to have something that can encapsulate our code, make it more modular, and avoid some namespace pollution. So we're going to be doing a cool little trick here that will be utilizing and leveraging the IIFE. So we're going to have one of these. We're going to assign a variable a value of a function, but I want to take this function and I'm going to wrap it in another set of parentheses and immediately invoke it afterwards. So this is an anonymous function that is simply immediately invoked, hence the term IIFE, or immediately invoked function expression, aka the IIFE, a common pattern you may and will see in programming all the time. I suggest you get used to seeing these and using these because they can be pretty instrumental in helping you out in certain scenarios, right? So again, this is kind of like, you can think of it as like a self-invoking function. So remember the first set of parentheses simply wraps our anonymous function come on, there we go, simply wraps our anonymous function so it's self-contained inside of there because it doesn't have a name of any kind. And the second set right here is what invokes it right away, and that's what we're looking at there. So yeah, like I said, they're pretty much just self-invoking functions. Its primary use and what we're going to be using it for specifically is keeping the global namespace clean. Now, when I code React projects, a lot of the times I have utility functions that I will code as hooks or within components, which are functions in React, and I can pass them around as props. Now, because those components will go in the global namespace, I have to be careful about that here in an old school JavaScript project. I'm not just going to be declaring a ton and initializing a ton of variables in the global namespace, because the chances of having variables shared across games that may be scripted or linked on the same page could be an issue. I don't want to have like game over the variable, which would probably be like a Boolean. Like if I declared game over here as false, or if I accidentally declared it as true, I don't want this variable in the global window object of the browser with another script that might have to use a similar variable to cause issues, right? So global variables and functions will easily clash if multiple scripts are included on the same page. So I'm doing a little bit of foresight, and saying, no, we're going to avoid this problem by simply using an IIFE to house the core functionality of our games. Like I said, this has a lot of advantages. Namespace pollution. We're going to avoid that crap, which is awesome. The other thing that I talked about from OOP is encapsulation. So we're going to have everything wrapped, our game logic, wrapped inside this function, providing a clear private scope for variables and functions, so I know where they all are. If I got to find the memory game, I come to this memory game IIFE, and that's where I'm going to find everything. That also leaves things hidden to the outside world. Our students from our advanced web development course may have remembered this about scope and lexical scope and environment and things like that. And I told y'all that closures were a common way of hiding variables from the browser in a way. Again, if it runs in the browser, technically nothing's super hidden, but it does make it so it's harder to find and gain access to manipulate any kind of variables written inside of a function like we're about to do here. So it gives us the ability to reuse this if we want to. It gives us, again, the ability to initialize things right away in the background without having to rely on a call script, on a call of any kind. We're going to do that anyway. We have tons of local scope for variables, which gives us some security, because if they're not in the global scope, then the surface area of what malicious scripts can do is definitely going to be limited, because all of the internal functionality of this game will be hidden inside of the scope of this inner function. So there's a lot of benefits to doing it this way. And again, it's one of those things that as a newbie, you wouldn't think to do this kind of stuff until you build something of a decent enough size to where you start running into those problems and you're like, crap, I could have done this from the beginning. So this is what would make the difference between like a beginner, and intermediate, and senior developer, which was, just knowing not to code for the problem at hand, but how to code for the problem at hand while also taking into account future edge cases and things like that. So there's a lot of benefits to doing it this way, and we're going to do it this way. So let's go. We're going to code out an array. An array works. We'll do an array of card types. That way, if I ever want to change my cards to be something other than just letters like we have now, I'm going to be using this array to do that. So I can dynamically generate the array later, maybe via like a slider option for how simple or complex the game needs to be. I don't know. But ultimately, this is what's going to represent what cards we have on the screen. So let's go ahead and do 2 pairs of cards. That way we have 2 possible selections of our cards to match on the screen, because it's ultimately going to have to be an even number of cards, considering it has to be a pair of cards that are going to be matched over and over again, which I think is funny that I have 3 cards here, which is fundamentally the incorrect way to play the game. I realized after I finished the first video. Okay, so those are our card types. I need to also track what cards we have flipped. And there's a couple different ways we can do that. I can do an object with keys and values. I'm just gonna do another array, but I will be reassigning this thing over time beyond just in-place manipulation. So I'll be doing flipped cards as an array. So as I flip cards, I will track what cards I'm flipping in this array. That way I can know when a pair of cards has been flipped and to check for either them being a match, or if they're not, flip them back because they weren't a match. So I'll eventually use this. I'm gonna go ahead and initialize it and tell y'all it will track our pair of flip cards to check them. But we're not going to use it for a minute because we got some other game logic to get to. And eventually, I need to know when all my matches are done. So I need to count how many cards I have matched. Because when I have, out of these 4 cards, when I have 2 pairs that are matched, the game is technically complete and over, and I need to count with that with a reset game, some kind of message or whatever. So we need to track that, and that's as basic as we're going to go ahead and get for now. There'll be other ones I'll probably declare and initialize up here eventually. Now, I would like to generate the cards from our JavaScript from this array of cards rather than directly here from the HTML, because like I said, that'll be boring once people figure out what all the cards are. It's not going to be very dynamic. So let's make utility functions to help us here, right? So we're going to be creating cards. I'm going to call this create card element of type because these string values, whether they're characters or emojis or symbols or something goofy I put in later, I don't know. I want to pass in what type it is and just use it in that regard. So what this thing we'll be doing, this function is going to create the element as a jQuery div and return that to us so we can use it to attach listeners, and do other things with as needed. So I will say this function will return something. And I will be like, yo, jQuery, I want you to return a string. And not just a single quote or double quote string. We're actually, that zoom level's fine. We're going to do this as a template literal, which are the backticks, which is your tilde key below your escape and above your tab key on your keyboard. The backticks are like a string with different features. It's called a template literal. It can be like a normal string, except it doesn't use string concatenation. You don't do like LOL plus type, for example. You don't do that with these template literals. What you can do is do $ curly braces. Now remember, this $ curly braces is not related to jQuery. I have a lot of newbies that tend to get confused with that. If they learn template literals too early, they get confused between $ parentheses as jQuery and $ curly braces as string interpolation. So think of interpolation as the fancier way of concatenating variables into a string message of some kind. Think of it like a surgical tool where you say, I'm going to make an incision here to insert something, right? So $ curly braces in a set of backticks is how you type in a variable dynamically into your string. The other big benefit of template literals, unlike vanilla strings, is that you can do new lines in between them and they are maintained. Now, the reason I'm choosing it to do it this way is because the interpolation will be far easier than string concatenating. And the other reason is that way with this new line feature of template literals, I can write like pseudo-looking HTML inside here. Now, it is HTML, but at the end of the day, this is just a string value in JavaScript that will be interpreted by the $ parentheses of jQuery, and will create this element, right? This will allow me to write HTML like I know it and append it to the DOM, and aka make it appear here just like our current cards are doing in our game board and parent class card, 2 card faces, 1 back, 1 front, okay? So, and this is exactly where React would be super nice because JSX is basically this right here that allows us to autocomplete tags, attribute highlight, all that kind of fun stuff. Unfortunately, right now, we are just in a string value, which means that any typo I make, like if I write class equals and I forget the double quotes, something could go wrong here. So you got to be very careful on your syntax inside of here because you're not going to get any kind of error highlighting like you would from a React JSX component. So remember, we have class card as our main div. I'm going to go ahead and write 2 divs here and copy and paste them because we're going to be doing something similar between both. I'll go ahead and write class equals on both of them, and they're both going to get card face, and they're both going to get card dash, with one getting back and one getting front. There we go. So there is the general structure of our cards as we have them at the moment. The back has that question mark as our cool little logo on the back of the card, that gradient we made in the last video. And I'm going to go ahead and string interpolate the type parameter. I'm going to pass in the function argument, the type, that parameter. We're going to pass in and interpolate as whatever the value of this card is going to be. A or B doesn't really matter, right? So I think this is perfectly fine for this utility function. It did its job. We could actually code all this out in one function and call it a day, but the whole purpose of keeping it functional like this and reusable and modular is whatever things I can house into utility functions, I will do so. That way everything has like a specific purpose and job where I would go and debug problems. Now, I'll say that as of right now, this function simply being invoked will create all these things, but it doesn't mean it actually runs anything, right? So what we have to do well, you don't have to, but what I'm going to choose to do is I'm going to make something here called initialize game, where I will tell the game what it needs to do. So let's go ahead and do the following. Let's call create card element. Let's pass in type A, just a manually written type. Eventually it'll come from this array up here. But for now, I simply want it to generate a hard-coded A to test with. And I want to take this card, which I'm putting into a variable for now, and I want that to find the game board, which is class game board, the div that they're all going to go into. And I would like to append into it the card element I have just created. Now, at the moment, just like we can currently see, we are not calling initialize game, the function, from anywhere in my code base. But remember, this is all returning into a variable called memory game. So what we're going to do is head down below our IIFE. We're going to say, now, because my script is in the bottom of the document body, I don't have to worry about, hey, telling jQuery to prepare it for the DOM content to load. But it still is sometimes a practice to do so, where you'll say, when the document is ready, aka the DOM content has loaded, aka the game board and this card, then the jQuery script, then my script finally runs. It should say the document's ready. Now it's time to run this code. So I will go ahead and house it in here, even though this is not explicitly necessary with the way I have it set up. And we're going to say memory game dot initialize game. And there you go. This will be when the page loads, this script will run. And then when it confirms the DOM content is loaded, it will then take that variable, which ran the IIFE, and run the initialize game function on it. Or better yet, I can make it. Here we go. This will be much better, actually. We need to return something because it won't know what initialize game is, because this function, if it doesn't return anything, then memory game won't know what initialize game is. I knew that. So this function has to return something for that to work. You know what we're going to do? We're going to do it this way. There we go. I'm going to go ahead and make what we're going to call a public API. Yeah, we'll do it that way. Much better. So what this means, public API or action programmable interface, is the thing that gets returned from my IIFE into the memory game variable. There we go. And if you can highlight it, now it actually does something, right? See that? That's TypeScript. The IntelliSense is based off of TypeScript. If y'all don't have any experience in it, check out the community membership link down below in the description. We have some TypeScript content in our course. I'm making a standalone TypeScript course, as a matter of fact. So yeah, the public API or action programmable interface for my newbies out there means what you could interact and use with in your console in the browser. Because like that game is there, that memory game, see, it recognizes the variable is there, and it also recognizes that variable has a function on it called start, which means I can interact with it here in the browser. This is in the global scope. But what I don't have access to is memory game dot, and for example, it doesn't have the parameters, the other functions or the other variables, because I'm not returning them because they are stuck or privatized in the scope of that inner IIFE. So this public API what we return here is what's available outside of the scope of the IIFE, aka any kind of variables we want to read or write to, as well as any functions that will be available to call. So this is what will expose to the actual console in the browser, what can be accessed from within that IIFE, aka this thing up here. So we're going to make this part of the public-facing API. Everything else will be internal tools for it to get the job done. Now, I refresh the browser, and yeah, look, it works. So remember, one is coded from the HTML, or rather hard-coded from the HTML, and one is added from JavaScript. So if I get rid of the HTML one and only leave a nice and simple game board div and refresh, we are back down to a single card ready to go without the click listener on it currently. So there you go. We got the card going. So what we need to do now is we need to have a way to place all the cards from the array on the screen and eventually shuffle them as well. And we're actually going to cover a cool technique in shuffling. I already have a giveaway here in my tabs if you can read them. I don't know if I can zoom in on those specifically. I need to find like a tool that allows me to do like a little highlight, like magnifier zooms in there. If anyone has like a tool on Windows they use for that, please let me know in the comments down below. Yeah, we are gonna place all the cards on the board and not just one. So I could write that logic in initialize game, but you know it. Let's write ourselves a function whose purpose is to place the cards on the screen instead of what we have written here. So what we're gonna do is say const gameboard equals, hey jQuery, go find my anything called gameboard in the DOM that has that class. Now, thankfully for me, I only have one game board in there, but this selector I will have to be careful about later just in case. So in case anything is currently there, let's go ahead and just empty out the game board because, well, if we're restarting the game, for example, this might be a handy thing to have. Simply, instead of having to have a entirely custom reset function, calling place cards should allow us to just empty the game board from what's currently in there and place the all new cards in. So we're going to say, go through the card types array for each, again, for newbies, this is a shorthand ES5 array method that does a for loop, albeit a little bit less, tiny bit less optimized, but for this size, it doesn't make that big of a difference, where we pass a callback function for each element in the array. Remember, each element is simply a string value. So I'll say for each type of card in the card types array, we're going to run the following code. I will create that, and I'll be specifically calling it a card element. Shout outs to Stripe. If anyone has messed with that API, you are very familiar with the term card element because you had to do that a lot in Stripe and React. Also in our course, in my backend course, if you're interested in that, I covered third-party APIs, how to implement Stripe and Mailgun. I have little topics on that in our course. Yeah. We're going to pass in each type as we loop through it. It'll create a new card for each type of div we're creating. And I'll ask the game board to append to it the card element that was just created in this loop. And just like always, I'm being cautious of referencing using the selector into a variable because it just has to find it one time, because technically this runs a selector every time to go into the DOM and find the game board. And I don't want it to do that every time the loop runs, which is why I chose to put it into a variable rather than write, hey jQuery, find the game board. Hey jQuery, find the game board. So instead of, if I have 100 cards, I don't want it to find the game board 100 times. I need to find it one time and store that reference into a variable and use that variable instead. So there you go. That should theoretically place all of our cards into the game board in the, but from the array. So all I'm going to do now is an initialize game. I'm going to call place cards like that. And survey says, would you look at that? We got the 4 cards in the DOM, and in the game board, we got the 4 cards A, B, and B. So there you go. We did it, y'all. Let's get the click action going back on the cards so it's not as boring to look at here. So yeah, let's go ahead and do that, because this actually brings up another fun topic that I have done a little bit of research on because I was curious about what's better, because I see a lot of my students and even myself would still just add click listeners directly to an element. But I'm going to bring up a cool topic here that's a little bit more advanced than my beginners are probably familiar with. And let's just go ahead and write it out and I'll show you what I mean. We'll call this add card click handler. And rather than adding the click handler to each individual card, which I would have to do like up here where I create it or inside of here for the card element, I mean, I could do it either way here, where I could say card element dot click, for example, and run a click listener on it that runs the logic for it to run. But that's starting to mess with the logic up here of place cards, because this is about placing them onto the game board and not necessarily creating its click event listener. It could make sense down here, because if I write dot click, the way jQuery works is that the context of the dot will be the thing furthest to the left, which happens to be this div. And I think it actually places it onto the parent card, which is what I'd want it to do. But again, that begins messing with, this creates the card element. This shouldn't have to deal with events on the card itself because that would begin polluting it there. So it makes sense to add an add card click handler. And you're wondering, okay, but which card? How's it going to know which card we're putting this click handler onto? How will it not accidentally stack multiple click handlers on the same card every time we add more? How do we know and tell it which one we're adding it to? So this is a cool concept we're going to call event delegation. And we're going to do this and think about it as like a teacher supervising a classroom of students. And this teacher, instead of having to individually check every single student's work, they would just sit at their desk and watch the whole class. If a student raises their hand in the class, the teacher looks to see who it is and is like, "Yo, Joe, what's your question?" "Yeah, is this woodshop class?" So, you know, like that's what you probably experienced for those of us who went to public school or, you know, well, probably any school, honestly. I don't mean, maybe it's different across the world. But for us US kids, you probably sat in a classroom. If you had a question during like a study hall or something like that, you raise your hand, you get called on, and you get to ask your question and get help, or the teacher comes to you to keep things quieter in the room, for example. The point being, they don't stand over every single student at every single minute of the class to see how they're doing. They basically delegate the event to us and respond accordingly. And that's exactly the same approach we're going to take, because in web development, that analogy of the teacher waiting for a student to raise their hand to address them individually is what we're doing with event delegation. Instead of attaching the event handler to each individual card, we're going to attach the event to the parent container. And when the event occurs on a specific element, like a click, the event bubbles up to the parent container. I actually have a whole Codepen about this. I'm going to link it in the description down below, but let's take a look at it together here. At least I'm pretty sure I do. I can't believe I took the time to make this. This is so stupid. All right, so I made this Codepen where I was showing students what event bubbling is. Now, the query selectors, they all say box. They say box instead of circle. I don't, whatever. The point being is that these divs are nested in each other and they each have their own individual click function. So the outside box or circle or bubble is bubble 1. The inner one is bubble 2, and the innermost is bubble 3. They each have their own click event that says you have clicked 1, you have clicked 2, you have clicked 3. So look what happens if I click the outermost bubble. The purple one has been clicked. If I click the inner one, it logs, let me clear it. It logs 2. It logs first, I clicked the inner blue bubble, and it also logged that I clicked the purple bubble, but I technically didn't I? I clicked the blue one, not the purple one. And as you can imagine, what happens if you click the innermost one? Then, clear. Then if I click the innermost one, all 3 events have now been fired. What the heck, man? If I click the innermost one, why did all 3 fire? This is because in web development, an event will bubble up to all, it will like propagate up all the parent elements and trigger the same events they have everywhere else. So we are using this to our advantage here. Now, for this Codepen, I'll have it linked in the description down below. Tell me in the comments how you would stop this event from happening. Tell me what code you would add to this Codepen in order for the events to be single. Meaning, what would I change for clicking the green bubble to only log you have clicked the green bubble and not the other 2 firing as well, because that's a different way to approach this, but that's not what we're going to be doing here. So I'm going to set this tab aside because that's going to be, I need to remember to link that in the description down below, but we're taking advantage of that, right? So we're going to take advantage of the fact that if I click on a card, that click will bubble up to the parent which will be the game board, because remember the cards appear in the game board. And what that's going to do for us is going to have the event delegation be on the parent container. When it happens on the specific element, it bubbles up to the parent, and the parent will check which child triggered the event, like a teacher figuring out who raised their hand, and responds accordingly. This is more efficient because we only need one handler for many elements, making our code simpler and faster, right? It works well if new elements are added later, meaning if we're adding a dynamic amount of cards, I don't have to add a dynamic amount of handlers. I have one handler that will listen to all cards in the game board, right? So basically, it registers on the most common ancestor element, which is the game board. That's the fancy terms you'd want to use. If it bubbles up to that, it checks who it originated from, and if it does, it handles the event. So here's how we're going to do it, right? So in order to use this lovely new thing I have now taught y'all, we are going to do it as such. We're going to say, hey, jQuery, please find the game board element and add to it an event listener. So on any click event that occurs inside of you, specifically on the card elements. So you can pass this additional parameter in the jQuery on event listener, saying for click events on card elements or div elements, these class card divs, if they are clicked on, this is our event handler. We're delegating this as the event handler. So that is the magic of how we're going to do this, and we've learned something new. Event delegation, efficient, optimized, fast, dynamic, right? It has all benefits if you understand how to use this. So, because we learned yesterday about closures a little bit, I covered it rather, we got to remember that closures are an important part of how that set timeout worked on flipping, knowing which cards need to flip back. So if you recall from yesterday's code, that's why I did I might as well just copy and paste this. This is going to be fine here, right? So, boop. We can copy and paste from yesterday's code. If you happen to delete yours and not leave it in, you can always just pause the video momentarily and take a look at this. I will grab the element we clicked on, will still be represented by $this, parentheses this, which is the jQuery element that fired the event that it came from. We'll capture that as the card, add the flipped class, and then after 1 second has passed, we'll simply remove the flipped class after that occurs. So this should be ran after we create our cards on the screen. So I'll say add click handler up here inside of initialize game, so we can't forget to add that. And refresh. There you go. We now have the event handled back on. It's being delegated by the game board to watch click events happening on the cards within itself. All right, y'all. Let's see, 32 minutes. I got time for this. All right, I'm going to cover one more thing in this video and then now about wrap it up to make these a bit more digestible and modular and not having people's eyes glaze over like on a 4-hour-long live stream. I'm going to try and make these more modular for us. So, yeah. I'm going to teach y'all, I had the jQuery cheat sheet open, even though I haven't used it yet. We haven't actually gotten that complex in anything jQuery does. This is, I'll put this in the description down below, but if you just Google jQuery cheat sheet, it'll be one of the top 2 results on Google. I do this a lot when I develop, and I'm surprised that a lot of individuals don't. I like having a high-level overview, a quick reference to all the API of jQuery, even though in case there's something I see here, I'm like, wait, this looks like it might solve my problem. I don't know what it means, but I see, prepend might be something I want to know how to do. And if I don't know what it means, I can click on it. It'll take us to the API, or at least it gives me something new term-wise to look up and learn about when it comes to using some library, framework, or something I'm working with, right? So I love having a quick reference guide in order to give me some new terms to start looking up in case I don't know what I need to do or how to do it, right? So that's why I like having cheat sheets up. Now, I only have 4 cards, so there really isn't a whole lot to shuffle, right? Because I don't want them always to be AABB, because that'd be very obvious what the answer is in this memory card game. So how do we shuffle the cards? There's different ways of doing so, and we are going to learn how to do it with something called the Fisher-Yates, or I think that's Newth shuffle. It is a common algorithm for shuffling a finite sequence of elements. The algorithm takes a list of all the elements of a sequence and continually determines the next element in the shuffled sequence by randomly drawing an element from the list until no elements remain. The algorithm produces an unbiased permutation. Every permutation is equally likely. The modern version of the algorithm takes time proportional to the number of items being shuffled and shuffles them in place, which is a very important thing to know. It is memory efficient because it modifies the array in place. It doesn't make a new array that has to grow out of the original array, right? So this is a modification of it, but nevertheless, I wanted to show y'all what this thing looks like here. Stop it. Basically, if we have an array of Elvis of these cells, again, it starts at 1 instead of 0, very annoying for us programmers, but again, this is not written for JavaScript indexes in mind. So basically, we start at the end of an array and work our way backwards. So immediately, for array length minus 1, I greater than 0, I minus minus. We start at the end of the array and we work backwards. And then we basically generate a random number from 1 till up till our current position. So if the end of our array is 5, we roll from 1 to 5. If it rolls a 5, we just pass. Nothing really happens. If we roll, and then the next one is rolled from 1 to 4 because the S has been placed. So the I minus minus goes to index 4. At index 4, roll a 1 to 4, and it rolled a 1 in this example. So it then takes the current place, 4, swaps it with 1. So E and I swap, and then it goes down I minus minus to the third cell. Roll to 3, it passes, places, minus 1 goes to cell 2, or element 2. Rolls a 1, those two swap, and then it's done. So as you can see, it starts at the end, moves in, rolls a number, swaps. Moves in, rolls a number, swaps. Moves in, rolls a number, swaps. So that is how this algorithm works. So what we're going to do in terms of JavaScript is loop through the array, start at the end, and move towards the first, right? Looping backwards ensures that every card is considered for swapping. Because again, every single time we roll a random number of the cards that are left to swap, we want to make sure that every card is considered. So we start at the end and just go back to the beginning. So no matter how many swaps happen, every card in place should be considered. We need to generate a random number, which we're going to call j. So the outer loop will be, loop will be I, the iterator I like always. The random value we're going to calculate, this roll example they have here, we're going to call that j. So I can write on the screen here. So this will be our j variable, and this will be our counter I, this iterator that is going to be moving inwards, right? So it's going to be I minus minus, and then this j over here will be randomly calculated. It's what's going to happen here. And it's going to be just some math. It just has to generate anything from between 0 instead of 1, because remember, we're working with JavaScript arrays, so it starts from 0 and up to and including I, as you can see here. So if I starts at 5, it needs to be up to and including 5. So basically that's 0 and I inclusive, right? So it'd be basically one of these. 0 less than or equal to j, which needs to be less than or equal to I. So we consider this basically between 0 and I, and we call that inclusive because it includes I. And this randomness is crucial for ensuring that any card can be swapped with any card in the array up to and including the current position. So they pass in this one, we're just going to go ahead and swap them all and call it a day because that'll be less code for us to worry about. Then all we have to do is use a clever ES6 trick to swap array elements, and then we're done. So ultimately, this has been a lot of explaining for an otherwise fairly simple bit of code. But again, knowing the term to it will make us better developers, and if you ever encounter this in an interview or something like that, and you can explain this is called the Fisher-Yates Shuffle, you will look so cool. There's nothing cooler than a guy at a party that's going to come up to you and be like, yo dog, you ever heard of the Fisher-Yates Shuffle? And they're going to think you're talking about a dance, and you start talking about array index positions and random numbers, and the person you're talking to will be so blown away by your knowledge, they will literally be falling asleep with their eyes glazing over with their red solo cup in their hand. You'll be the life of the party if you can describe the Fisher-Yates algorithm. All right, so let's shuffle these cards and then call it a day. Function, shuffle cards. Boom, that's what I'm talking about. Easy peasy. So like I said, we need to loop through the array. We're going to say let I equal array, which in our case is card types dot length minus 1. Remember, in JavaScript, the trick is the length of the array minus 1 is the final index position. Just memorize that. Continue this loop so long as I is greater than 0. That's our last element of the array. And simply subtract 1 from the array every single time. Yeah, every single, is that right? I feel like that's right. Every single time. Okay, and then from there, what we need to do is, like I said, calculate that random j index for our swap. So we'll say const j is a math.floor of a math.random multiplied by our inclusive range, which would be up to and including I, right? So that's going to be our inclusive range right there. Now, here's the really cool part using what's called an ES6 destructured swap. So bear with me now, right? So that looks nonsensical, but bear with me, right? So like I said, we're going to destructure the assignment for I and j and basically swap their values, right? So what's going to happen here is we're going to say the new value in the array at position I will be whatever is generated for j. And then whatever at the new array position at j will be whatever the position was at I. And there's our ES6 destructure swap. Pretty fancy, right? So once again, we have, remember, the right-hand side of JavaScript assignments will be calculated first. So it'll calculate the j. The I is simply iterating. So at position j, it swaps that to position I. Whatever the value is at I, it swaps it to position j. That's how the swap occurs. So that's all this code does. It takes the values on the right-hand side by pulling them out in the array and simply swaps them with those index positions and just goes to the array, swapping, swapping, swapping until it gets to the beginning of the array, and then it's done. So that is how our Fisher-Yates algorithm, shuffle algorithm, has been coded here inside of this particular game. So all we got to do now is ask it to shuffle those cards. Yeah, I'll do that first. We'll say shuffle, then place that. Yeah, we have to do it that way. Shuffle, then place, then add the click handler to our event delegator, the game board itself. And that should be all we need to shuffle the cards. Now, I only have 4 cards total with 2 types, so there's not going to be a lot of random. We can get ABAB, we can get AABB, we can get ABBA, or we can get BBAA or BABA. So there's not a lot of permutations we can get for this particular size of an array, but nevertheless, we should be able to hopefully see ABBA. So we got ABBA refresh. ABAB, so you can see it's shuffling. BBBA, yeah. So there you go. Every time I refresh, or eventually when we click new game, it'll shuffle the deck of cards for us, y'all. How cool is that? So now we have a cool shuffled card deck every time we replay the game or eventually have a refresh game or restart game button. We have a new set of memory cards. This game is no longer going to be boring as crap once someone figures out the pattern. Now, we still haven't prevented anybody from cheating by just going to the DOM over here and looking up what the card's values are. But granted, I mean, you know, if they're taking the links to do this, I don't know. Maybe we can find a way to like encode this to make it annoying to find out what it is, or give them some false positives, or break it up into other divs or things like that. I don't know. I'll find a way to prevent cheaters, maybe, but that's not really the scope of this game. It's just learning some cool logic along the way and some cool tricks, not necessarily how to prevent cheaters from cheating at the game. But yeah. That's it for this video. In the next video, we're going to continue doing some additional code in terms of, you know, we need to have better logic on how to flip the cards. So this right here is fine for what we're currently doing, but I need to actually do some checking. Is the card already flipped? We need to then do 2 cards at a time. So we need to think, okay, if I click both these cards, if I click one card, it should stay because I'm matching. So if I click one card, it should stay. If I click a second card, if they're a match, then they're both disabled somehow. If they are not a match like that, then they should both flip and then flip back over and stay enabled. So I have to have some logic to prevent multiple flips on the same card like this getting it stuck or broken somehow. I also need to make it so one card will stay flipped until I select another card. From there, the logic is, are they a match? If so, disable. If not, flip them back over and let the user keep guessing. So the rest of the game logic will be done in the next video, as well as whatever I can get done in terms of the interface on the screen for starting a new game and messages beyond the console log and stuff like that. So as always, do the YouTube stuff, like, comment, and subscribe. Get involved in the comments if you have ideas for the game, how the website should be laid out, maybe some old, I'm not a game developer, so anything complex, like, oh, I build like World of Tanks there, dude. I'm like, yeah, I'm not doing that. We'll see how far I get in terms of how many crazy games I make. But I'm having fun so far, especially just using old school jQuery and just learning fundamental solid web development techniques. And yeah, I'll see y'all in the next video where we continue this game logic. So I'll see y'all there.